All right, we have an object moving in a straight line with positive acceleration. Let's be really clear here. So let's identify each graph. This graph is for an object at rest. This is moving forward at positive velocity. That's constant positive velocity because the slope is steady. Here we're moving back at constant velocity. Here we're moving forward at gaining speed. That's D. Here we're moving back and speeding up. All right, now a ball is thrown straight up from a height of 2 meters, goes up to 3 meters above where it started, up to a height of 5 meters, and then it drops back down to the ground. And we want to know the displacement. So the displacement, delta x, is 0 minus 2, which is negative 2, 2 meters below. What do velocity and acceleration have in common? A scalar is only a number. False on the units. False on the units. Absolutely not. Both are vectors. They have size and direction. All right. Two projectiles will launch with the same initial speed, but they have different angles. So I'll just tell you right now, the larger the angle, the larger the hang time, and the larger the height. So bigger angle implies bigger height, and bigger hang time. It does not necessarily imply bigger range. So what that means is H60 is going to be bigger than H30, and T60 is going to be bigger than T30. If you wanted to prove this, you could say T is V naught squared. T is 2 V naught sine theta over G. Then you could plug in 30 versus 60. And that would actually rule out this one and this one and this one. And then you could do the same thing for the height. And you'd also see that 60 degrees gives you a bigger height. So that would rule out that. So we're left with choice E. And then number 5, an object of mass 100 kilograms is initially at rest on a horizontal surface. A 10 Newton force is applied to the object for 1 second and then removed. Which of the following is true? The object time t equals 2 if it is on the surface and it's a frictionless surface. False. It will start moving. It will not move. The acceleration stops. There's no decreasing acceleration. It's just done. It will not come to rest. It is not accelerating. It will continue moving at a constant speed in a straight line forever. That is Newton's first law. So when an object is in equilibrium, the net force acting on it is 0. It has no acceleration. It is not necessarily, well, and when we say equilibrium, this is true and this is true. It might be doing this or it might be doing that. So only 1 and 2 can be guaranteed. 7 and 8, these are projectile motion questions. So we chuck a rock v naught at an angle theta. The horizontal speed, if you remember, when we split up the components, Vx is v naught cos theta, Vy is v naught sine theta. Only this changes. And at p, it equals 0. However, this is constant because there's no acceleration in the x direction. So at point P, that rules out B and E. The acceleration is always g in the y direction. So that rules out choice C. And so at the very top, Vy is v naught sine theta. No, not at the top. At the launching, v naught y, v naught x, v naught y is v naught sine theta. However, at the very top here, Vy is 0, which gives us choice A. And then the acceleration, when we want to talk about speed and acceleration, horizontal, vertical speeds and acceleration. Interesting. It seems like this question repeated. Let me read it again. Okay, so which of the following correctly describes the horizontal and vertical speeds and acceleration of the rocket at point P? At point Q. Okay, so now that we're at point Q, we actually have regained our v naught sine theta as our speed. So that gives us choice D in the y direction. The v naught sine theta comes back because it speeds up because of gravity. All right, so that is your practice test.